Hello class, happy Friday, and today we're going to be starting with types of chemical reactions, a review from grade 10, and then I'm going to be assigning a worksheet for today. Hopefully you finished your balancing equations worksheet, and please have it in by the end of today. Okay, so hopefully you learned in grade 10 there are four main types of chemical reactions. There's synthesis, which means you're making something bigger. So you're combining two smaller entities and making something bigger. Decomposition is the reverse of that, so breaking up a bigger substance. And single displacement and double displacement. So that's what we're going to be talking about today. And our goal of our lesson is to recognize the different types of chemical reactions. Okay, so synthesis means you're combining two substances to produce one new substance. So A plus B forms AB. Okay, so some examples are metal and a non-metal forming an ionic compound. So when you combine sodium with chlorine gas, you make sodium chloride. That's a synthesis reaction. A metal and a non-metal combining metal or a non-metal combining with oxygen to form an oxide. So in this case, magnesium combining with oxygen to form magnesium oxide. Next is carbon plus oxygen forming carbon dioxide. Metal oxide with water forms a base. Here's another example. When you combine magnesium oxide with water, you form a hydroxide, so notice this is one big compound coming from two smaller entities. Non-metal oxide with water forms an acid. So if you combine carbon dioxide with water, you get carbonic acid. Okay, decomposition is the reverse. So it's breaking up of a compound into simpler substances. So you just do AB and you break it up into A plus B. Okay, so these reactions are much harder to predict than synthesis reactions. Examples are decomposition of water. So water is going to break down into hydrogen and oxygen. The decomposition of calcium carbonate is going to make calcium oxide plus carbon dioxide gas. Okay, single displacement reactions. So basically, you are combining a compound with an element, and the element comes in and kicks out one of the elements. So X comes in and kicks out A and combines with B. Okay, or Y can come in and kick out B and combine with A. Okay, so some examples. Magnesium can come in and kick out silver to get silver plus magnesium nitrate. A nonmetal can also kick out another nonmetal. So bromine can come in, kick out iodine to get the results right here. So these are both examples of single displacement. Okay, double displacement is basically a double swap. Okay, so AB plus XY, they literally switch partners. So A combines with Y, X combines with B. So the way I always predict this is the outsides go together and the insides go together. Examples, lead 2 nitrate plus potassium iodide. Okay, they literally switch. So PB combines with I right here, and K combines with NO3. So these reactions are a little bit more tricky because you have to do crisscross when you're predicting the product. So you just have to brainstorm first before writing the products, because how would we know that it's PbI2 without doing the crisscross first? So knowing your charges and being able to crisscross is really important for this section. Okay, so we're going to go to the second PowerPoint here. And this is just another recap of types of reactions. So again, synthesis is when you combine A plus B to form AB. Simplest example is making water. Okay, these are some examples. Decomposition, breaking down of a reactant to make their products. Single displacement reactions. I encourage you to watch this video here. I am posting these two PowerPoints on Google Classroom, by the way. So single displacement, the magnesium comes in, kicks out hydrogen, and you get magnesium chloride. We are going to talk about the activity series list in a second, which tells you, can magnesium come in and kick out hydrogen based on the list of highest reacting to lowest reacting? So here it is. So the activity series list is basically to figure out which is more reactive. So is aluminum capable of kicking out calcium? So there's a list that's created that you don't have to memorize. It will always be given to you. And basically, the higher the element is on the list, the stronger it is. So if aluminum is higher than calcium, then it can kick it out and the reaction does proceed. Okay, if it was the other way around though, it would not happen. So here's your list, which is going to be given to you on a sheet that I'm going to be attaching to this post. Lithium is the strongest metal, and then down here, gold is the least reactive, thankfully, because if gold was very reactive, then it wouldn't be as precious, right? Because it would react with everything. Okay, so here, aluminum plus calcium chloride, does it react? No. So you just write no reaction. Why? Let's look at the activity series list. Is aluminum above calcium? No, it is not. Calcium is above aluminum, right? So that's why it is not able to kick out calcium. Calcium is higher on the list than aluminum, so therefore it is stronger and won't let this reaction happen. Aluminum plus iron 3 oxide, I mean. Is aluminum higher on the list than iron? Let's check. Is aluminum higher than iron? Where's iron? Okay, so on this particular list from the PowerPoint, it's not shown, but iron is lower than aluminum, which will be shown on your sheet that you get in this attachment. So aluminum is higher than iron. So therefore, aluminum is able to kick out iron, and then you have to predict the products using crisscross. And iron is just simple, you just write Fe. Is zinc higher than magnesium? Zinc, magnesium. So it is not higher than magnesium, so therefore the reaction will not happen. Okay, there's also an activity series list for halogens. Halogens have their own list. Fluorine is the most reactive and the least reactive is iodine. And let's do an example. Is iodine strong enough to kick out chlorine? Is iodine strong enough to kick out chlorine? So is iodine above chlorine? No, it is not. So therefore it is not strong enough to kick out chlorine, so there's no reaction. Is chlorine strong enough to kick out bromine? And it is, because look, chlorine is above bromine. So the reaction does happen, and then you have to predict the products using crisscross rule. Okay, so let's practice. Magnesium plus hydrochloric acid. You have to refer to your activity series list as you do these exercises. So let's look at our activity series list. Is magnesium above hydrogen? And it is. See? So the reaction will proceed. Okay, so how do we predict the products? We know that magnesium is going to combine with chlorine. So you have to do the crisscross rule. So Mg is +2, Cl is -1. You crisscross and you get MgCl2. And what's left is hydrogen. And remember, hydrogen never exists on its own. It always exists in twos as a diatomic. Next one, NaCl plus Ag. Is Ag stronger than Na? And we'll kick it out. Let's check the list. And it is not. Silver is way below right here than sodium, right? So it will not happen, as shown in the slide here. No reaction. Okay, this is H2O here. So I do want you to practice these reactions on your own, and I will be posting a worksheet on that. We are going to do double displacement precipitation reactions on Monday because it is kind of a long lesson about predicting solids in the reaction. So I'm just going to show you briefly what I mean by that. So when you combine a compound with another compound and they do a double swap, so PB reacts with I and K reacts with NO3, you do the crisscross, you figure out what the components are, and then you have to figure out, is a solid formed or not? If there's no solid, then you just write aqueous. We are going to be given a chart where we predict which solid is formed, and that chart I'll be giving to you on Monday. But basically, this is the reaction shown here. So if you add potassium iodide with lead 2 nitrate, this is what you get. The lead 2 iodide becomes this solid lump, which is called a precipitate. So we are going to be able to predict whether a precipitate is formed, and we'll be doing a virtual lab on that. Okay, so that's it for today's lesson, and watch the second video for an example on the worksheet I provided.